Welcome back. This is our Algebra 2 sequence and series lesson number 2, Arithmetic and Geometric Sequences Home Review Part 2. Please make sure to catch part 1. And in this case, if you have any questions or comments about the video, please leave in the comment section below. And anything you might feel be more helpful, or just anything that's not unclear, please make sure to put that there. Also, give this video a like if you find it helpful, and subscribe to the channel if you've not done so already. Okay, so we're now going to question number 3, where you see in this case, it tells us that x plus 4, 2x plus 5, and 4x plus 3 represent the first 3 terms of an arithmetic sequence. Then find the value of x. Okay, what is the 4th term? So in an arithmetic sequence, we know that the second term, since this we'll list a1 as x plus 4. They tell us that. a2 is equal to 2x plus 5. And a3 is equal to 4x plus 3. And because arithmetic sequence, we know that the difference between a2 minus a1, our common difference, must be equal to the difference between a3 minus a2. And we're going to use that to be able to solve for x. So let's set this up. a2, which is 2x plus 5, minus a1, which is x plus 4, must be equal to a3, which is 4x plus 3, minus a2, which is 2x plus 5. Now, the nice thing is in this equation that we only have one variable. So we're going to be very careful in this case with distributing the negative. So make sure we distribute the -1. And we're going to get 2x plus 5 minus x minus 4 equals, again, distribute the negative for the second one. And we will get 4x plus 3 minus 2x minus 5. And now combine like terms. So on the left side, we have 2x minus x gives us 1x, and 5 plus -4 is equal to +1. So x plus 1 on the left side. On the right side, we combine the 4x and -2x gives us 4x minus 2x is 2x. And then 3 minus 5 will give us -2. Now we solve for x. Again, I always subtract the smaller of the two variables, so subtract 1x on both sides. We have 1 equals x minus 2, adding 2 to both sides. We will get x is equal to 3. So we solve for our variable x. Now, if we substitute in, we'll see in this case, a1 is equal to x, which is 3 plus 4, and now it'd be 7. a2 is equal to 2 times 3 plus 5, and that will be 6 plus 5, which is 11. And then a3 is 4 times 3 plus 3. 4 times 3 is going to be 12, plus 3 is 15. That would mean, in this case, that if we see this here, our common difference of a2 minus a1 is equal to 11 minus 7, or 4. So our common difference d is equal to 4. All right, so we found our first 3 terms. So that's definitely the first part here. We solved for x. We found our first 3 terms. And then to find the 4th term, a4 should equal to a3 plus d. Therefore, our 4th term is equal to 15 plus 4, which means in this case, our 4th term, a4, is equal to 19. And that's how we find our 4th term, because we use our d value from before here that we calculated. Okay? A lot of work here, right? So again, what we do is we set up our situation of A2 minus A1. That common difference is equal to A3 minus A2. It allows us to set the terms in a way so we can solve for the missing variable x. And then be able to, once we solve for x, be able to find the first term, the second term, the third term. And we do see in this case that the common difference between any two consecutive terms is going to be 4, which would mean in this case to find the next term, we just add that common difference to A3 to find A4. Okay. For number 4, f1, the first term is 12. And the rule we use is fn is equal to fn minus 1 minus 4. Which of the following represents the value f40? Okay, so again, when we see f of n equals f of n minus 1 minus 4, this is in the form for our recursive formula for arithmetic sequences. Fn equals fn minus 1 plus d. Okay, that's the recursive formula for arithmetic sequences. Basically, the previous term plus a common difference to find our next term. So if that's the case, we can see in this case our common difference equals -4. So we use our formula, and in this function form, we see that fn as explicit, in our arithmetic sequence form to find any nth term would be f1 plus n minus 1 times d. So it doesn't matter whether we use a sub n or t sub n or f of n, it's the same setup. The first term plus n minus 1 times the common difference. Now, how is it helpful? Well, our general formula, or explicit formula, will be fn is equal to, since f1 is 12, we'll have 12 plus n minus 1, and of course d is -4. Now distribute the -4 here, and we'll find in this case that the formula we use, fn, is equal to 12 minus 4n plus 4, or fn is equal to -4n, and 12 plus 4 is 16. And that's the explicit definition, or this explicit formula we'll use to solve for f40, because we're just going to plug in 40 for n. So f40 will equal to -4 times 40 plus 16, which really is going to be -160 plus 16. And therefore f40 will equal to -100, and I believe 144, because 160 minus 16, 144. -144. In that case, choice 3. Question number 5. In an arithmetic sequence of numbers, a1 equals -4, a6 equals 46, which the following is the value of a12. And so here we're not given the common difference, but we do know what the first term is and the sixth term. So in our formula for the arithmetic sequence for nth term, a sub n equals a1 plus n minus 1 times d, we can use some of this information to find the general form. And once we do that, we will then be able to find the 12th term. So a6, so that means a6, which is equal to 46, equals a1, which is equal to -4. Again, a6, put it this way. a6 equals a1, which is -4, plus, and since the n value is 6, we still don't know what d is, but we do know a6 equals 46. So let's have this equation to solve for d. So now we have -4 plus 6 minus 1 is 5d, and that's equal to 46. If we add 4 to both sides, we get our common difference, 5 times common difference is equal to 50, which means divide both sides by 5. Our common difference is 10. So we now know in this case our common difference. We still know our first term. We will now find our explicit definition. AN is equal to A1, which is -4, plus n minus 1 times 10. Let's see if I can move this down a little bit here. Yep. All right. So we were going to find our explicit definition. A sub n equals -4 plus 10n, because we're distributing a 10 for the n, and 10 for the -1, and minus 10. Oops. And that would mean that the nth term is equal to 10n. -4 plus -10 is -14. So this is the formula we're going to use to find, in this case, we're looking for the 12th term. So the 12th term, A12, we'll just, in this case, plug in 12. So A12 equals 10 times 12 minus 14. So A12 is equal to 120 minus 14. A12 is equal to 106, which is going to be choice 4. Okay? Now question number 6. The first term of arithmetic sequence whose common difference is 7 and whose 22nd term is given by 143 is which of the following? So again, we're going to use our formula here. A sub n equals A1 plus n minus 1 times d. Again, this is to find the nth term of any arithmetic sequence. But they tell us d is equal to 7. And A22 equals 143. All right, so that means when n equals 22, an equals 143. So now all we do is try to plug in the information we have here. We'll get 143, that's an, because that's A22, equals A1 plus 22 minus 1 times 7. See how that worked out? We plugged in d for 7, n for 22, and an, which is A22, 143. So now we have 143 is equal to A1 plus 21 times 7. And 21 times 7 is going to be 147. So 143 equals A1 plus 147. Subtract 147 both sides. We will get the first term, A1, is equal to -4. And that's going to be, in this case, choice 2. And this will be the end of our Algebra 2 Sequence and Series, lesson number 2, Arithmetic Sequences, Overview, Part 2. Again, if you found this video helpful in any way that helped you figure out how to do some of these problems, please give this video a like and subscribe to the channel if you have not done so already. Questions and comments in the comment section below are greatly appreciated, and I look forward to seeing you in the next video. Take care, everyone. Be safe.